Good day, everyone. Let's try to solve this algebra problem from South Korea taken from the South Korean Mathematics Olympiad. And here is the question. If x squared plus x plus 1 equals 0, we find the value of x to the 77 plus x to the 76 plus x to the 75 plus x to the 74 plus x to the 73. Now, as you can see, we are finding for the value of an expression with substantially large exponents given only a certain expression with a substantially small exponent. So what we're going to do is we are going to make a comparison of the two expressions and try to see if one form of the other can be substituted to the other expression. Now, let's try to have the x squared plus x plus 1 and the x to the 77 plus x to the 76 plus x to the 75 plus x to the 74 plus x to the 73. Now, we'll try to see if some or all of the terms of this expression can be rewritten into this form. So, since this has three terms, let's consider the first three terms here and see if these three terms can be transformed as so that it will contain this one. Now, as we can see, let's try to group this one here. Now, the terms here have a common factor, that's x to the 75. Now, after we take out x to the 75, you can see now that you have x squared plus x plus 1, which is the same as this one here. That means since the value here is 0, we can replace this by 0. So now we have 75 times 0 plus x to the 74 plus x to the 73. Now, since any expression multiplied by 0 is 0, we can ignore this one here. So the expression just becomes x to the 74 plus x raised to the power of 73. Now, the same thing that we are going to do here, we are going to rewrite this expression so that it would contain this expression. Or if not, we are going to transform this expression in order for us to find a suitable expression that can be substituted to this expression here. Now, let's try to transpose one to the other side. So we have x squared plus x equals negative 1. Now, we'll see if we can rewrite this as x squared plus x. Now, the reason why we transpose the negative 1, it's because we are only left with two terms. So we cannot substitute three terms to two terms. That's why we need to have two terms at least on one of the sides in order for us to be able to make a comparison as to this one here. So now, these are two terms. These are two terms. Again, we'll try to see if we can manipulate this part so that it will be the same as this one here. Now, if we can factor this out, we have x to the 72 times x squared plus x. Now, again, you have x squared plus x here, and you have x squared plus x on the other side. And since the value of x squared plus x is negative 1, we can replace this by negative 1. So now the expression becomes 72 times negative 1. So we are now left with x to the 72. Now, x to the 72 is a very large exponent still. And obviously, we cannot find the value of x to the 72 directly from this one. So that means we have to transform x to the 72 in an expression that will have a factor that will contain an exponent that is at least closer to this one. So we transform x to the 72, that becomes x cubed times, or x cubed raised to the power of 24 times negative 1. So now we need an expression for x cubed. So let's do that. Now for x cubed, we can multiply x squared plus x plus 1 by x minus 1 using the difference identity for two cubes. Now, since we multiply this one by x minus 1, we also multiply the left side by x minus 1. This will become x cubed minus 1 equals 0 because 0 times x minus 1 is 0. And this one, difference of two cubes identity, will give us x cubed minus 1. So that's why this is the result of the expression. Then here we can solve for x cubed. That's x cubed equals 1. Now, this one here, x cubed, will be substituted to this x cubed here. Since x cubed is negative 1, we can replace it by negative 1 raised to the power of 24 times negative 1. Now, 1 raised to the power of 24 is just 1. So we have 1 times negative 1. 1 times negative 1 is equals to negative 1. This is our answer, and the problem is solved. So that's it for this video. Please don't forget to like and subscribe to our channel for more challenging algebra problems. Thank you so much. Enjoy learning.